do problem 230, kth smallest element in a BST. So we are given a tree node of root and the int k, and k is an integer and we have to return the kth smallest value. So here if we put them in 1, 2, 3, 4, and k is 1, so we're looking for the first smallest, which is 1. And then if we put them 1, 2, 3, 4, 5, 6, we're looking for third smallest, which is 3, so we return the value of 3. So this question is very similar to problem 530. In both questions, we're going to use the properties of binary search tree, which is that when we go from left to right, we get sorted nodes from small to large. Because the properties of BST is when we go from left to right, the values of nodes increase. So we are going to apply in-order traversal. So that means we're going all the way to the end, to the left, and then we're going to get the root, and then we're going to get the right, and then we repeat the same process. So it's a DFS question. So we do need a private void DFS, and then it's going to take in tree node, node and int k. So this DFS method will recursively get called. So we're going to initially put root and k inside, and just our usual in-order traversal setup, we have DFS node dot left and then DFS node dot right. So this one will get called. We have to put in k as well. So this left method, this method will get recursively called until we reach the end, which is 1 in this case, and then because the left branch is null, we finish recursion and move on to the right one. So how do we detect the end of the recursion? So if node.val, if node is equal to null, we just return. And that means we finished recursing, and then we are at 1 now, so we have to do something. It's a very simple thing, we just need a counter really. So private int counter is equal to 0, and then we do if. We have to do plus plus counter because the first smallest is we're looking for the first smallest here, which is 1s, but our counter is 0, so we do plus plus counter is equal to k. We just set, we probably need some variable, say int var. We set var to node dot var, and then we just return. And if we do that, this will return and then get to here. But suppose there are like more branches, and they might end up doing calling this DFS for the right branch of this one. So to prevent this, we can actually have a private boolean found equals false, and then we can put additional condition that if found, and then here we can say found equals true. Okay, or we have to return file. All right, let's submit. All right, that's it. But just before we go through anything, if we have this if statement in front of here, it's not in order, it's pre-order. So we need to be very careful, because what this if statement did is after going through all the way to the end, we started working out the node. But if we have this if statement early, that means we are visiting each node as we go through the top left, no, the bottom left of the node. So the position of the if statement is very important.